Hello, this is Dr. Eduardo Alessandro from Brazil. This is a review on a recent meta-analysis that I'm going to present as a bonus assignment for our Module 3 of the PPCR 2021. So for this assignment, I chose a recent systematic review and meta-analysis titled Effect of Anticoagulant Administration on the Mortality of Hospitalized Patients with COVID-19, and updated systematic review and meta-analysis. So this article was published on the 4th of August 2021 at Frontiers in Medicine, which is an open access journal indexed at PubMed with an impact factor of 4.4. The authors are all from mainland China, named Luoqia Jiang, Yupei Li, He Yue Tu, Chang Tin, and Bai Hai Su. So the background is that anticoagulation is generally used in hospitalized patients with COVID-19 as thromboprophylaxis. However, results on mortality and risk of bleeding are inconclusive. So this review set out with a research question that we can interpret as: do hospitalized COVID-19 patients benefit from anticoagulation, both prophylactic and therapeutic dose therapy? So the primary outcome was in-hospital mortality, and the secondary was related to safety, for they analyzed the bleeding events or the need for transfusions of packed red blood cells. The methods that they describe, that this meta-analysis followed the PRISMA statement, the preferred reporting items for systematic reviews and meta-analysis, and was registered in the Open Prospero framework. The authors screened all relevant articles listed on Medline, the Cochrane Library, Embase, and Web of Science databases from inception to March 28, 2021. The search terms used were COVID-19, 2019 novel coronavirus infection, coronavirus disease 2019, and COVID disease 2019 novel coronavirus disease, severe acute respiratory syndrome, coronavirus 2, Wuhan coronavirus, Wuhan seafood market pneumonia virus, SARS-CoV-2, SARS-2, anticoagulant, anticoagulation, heparin, unfractioned heparin, UFH, fondaparinux, enoxaparin, low molecular weight heparin, low molecular weight, LMWH, thromboprophylaxis, antithrombotic, and antithrombosis. The eligibility criteria were that they would include randomized controlled trials or observational studies that compared the effects of anticoagulation versus non-anticoagulation on the mortality and or bleeding events of hospitalized COVID-19 patients. And the exclusion criteria were as follows. The first was the absence of original data. The second was the enrollment of non-hospitalized COVID-19 patients. The third was case series and reports. And the fourth, the absence of a comparator group. And finally, the fifth exclusion criteria was if the study was on non-human. So they did assess quality. The Newcastle-Ottawa scale was used to assess methodological quality of observational studies. And this scale has 8 criteria and yields scores ranging from 0 to 9. Studies with scores higher than 7 were regarded as high quality. The grading of recommendations, assessment, development, and evaluation grade framework was applied for rating the quality of evidence for each outcome in the pooled analysis. The statistical analysis, the variables were dichotomous. So you had mortality and bleeding present or absent, and was expressed as risk ratio with a 95% control interval. Heterogeneity was evaluated using the I-squared statistic and the Cochrane Q test, and a random effects model using restricted maximum likelihood was performed to pool the data. Potential publication bias was assessed by a funnel plot and also through the Baggs rank correlation test. And sensitivity analysis was performed using a random effects model and a leave one out approach. Also, they conducted 2 exploratory sensitivity analyses by excluding trials from the USA and from outside the USA in the meta-analysis of mortality. So the results, we have here the records that they identified. 4,421 relevant records. They retained 2,107 after dismissing duplicates, 2,060 excluded after abstract and title evaluation, and of the remaining 47 studies, they excluded 36 after full text review. Some of these studies were excluded because they were using oral anticoagulation as the control group. Some did not compare mortality between groups. Some included outpatients, and one had no adequate data. So a total of 11 observational studies were included in the meta-analysis with a pooled sample of 20,748 hospitalized COVID-19 patients with data regarding mortality, and a pooled sample of 11,302 patients with data related to bleeding events. All studies were retrospective in design. 7 of them were from the USA, 2 from China, 1 from Spain, and 1 from Italy. The mean age was over 60 years. Male subjects ranged from 47 to 69. Heparin and enoxaparin were the most used anticoagulants. The quality of included studies was deemed high, with 10 of them scoring above 7 on the Newcastle-Ottawa scale. And we can see here that some studies did provide confounder adjustments, but some of them didn't. And remember, these are all observational studies, which carry a lot of risk of confounding. So confounder adjustment is a nice strategy to better understand the data. Also, they have here the grade quality assessment, deemed quite high. most of the studies. We have here a funnel plot. We can see quite asymmetric distribution, but the authors decided to perform the bags test, and they considered through this statistical test that there was no signs of publication bias, although the image is quite asymmetrical. Also, we have here the forest plot that shows quite good results for anticoagulants, favors anticoagulants. The pooled total is 0.7 for the risk radio. Also, they did another forest plot just for the patients that were admitted to the intensive care unit, and the effect is maintained a little bit less, like risk radio 0.7, actually 0.6, 59, 0.6, a bit better. And here we have the forest plot for the bleeding events regarding safety, and we see that the risk radio is 0.9, almost 1, quite close. The diamond actually touches the confidence interval actually touches the no difference. So they considered it to be quite safe. Also, the authors did perform the sensitivity analysis, and we can see that also the results are robust because they are maintained, the confidence interval, they are all quite near each other. Also, when they performed the sensitivity analysis regarding studies from the US and from outside the US, the results also are maintained, so quite robust. Okay. So the conclusions that the authors came to, among patients, and I'm quoting now, among patients with COVID-19 admitted to the hospital, the administration of anticoagulants was significantly associated with decrease in hospital mortality without increasing the incidence of bleeding events. However, pragmatic trials and well-designed RCT studies with longer follow-up duration and larger sample size are warranted. My interpretation of this study is that this study displayed a good quality methodology with adequate description of procedures that do permit replication. Effect size model was appropriate, compatible with the variables. Heterogeneity between studies was noted, and the random effects model with maximum likelihood choice was adequate. Quality assessment of included studies was performed, as well as risk of publication bias and sensitivity analysis. But despite the robust results as expressed by the sensitivity analysis, this should be taken with a grain of salt. Although the initial screening included RCTs and observational studies, this meta-analysis ended up including only retrospective observational studies, with at least some suspicion of publication bias, despite the statistical test that dismissed it. The author's discussion and conclusions do point out these limitations and suggest the need for further investigations to actually elucidate this incipient evidence of benefit. Hey, thank you very much. See you next week. Bye-bye.